Hello, welcome to Power System Fault Section 3B. We will learn to calculate three-phase fault current in a simple power system network. Let's review the modeling of generator in three periods. It is represented with voltage source and reactance, which their values are different in each period. Let's learn from example. A generator is supplying power via transformer to load at the receiving end. All parameters are given. As shown on the screen, three-phase fault occurs in front of the generator. Let's start with calculating base current. Base power is 10 MVA, whereas base voltage is 18 kV. Therefore, base current is approximately 321 ampere. Convert load to per unit by dividing with base power. We've got load power 0.8 plus J 0.6 per unit and load current 0.8 minus J 0.6 per unit. We transform single line diagram to per phase basis circuit comprising voltage source, generator reactance, transformer reactance, and load. For subtransient period, we use subtransient reactance with the value 0.12 per unit. Therefore, the magnitude of voltage source, e.g. double prime, is 1.22 per unit. Then we calculate subtransient fault current. The magnitude of fault current is approximately 10.2 per unit or 3262 amperes. For transient period, we use transient reactance with the value 0.25 per unit. Therefore, the magnitude of voltage source, e.g. prime, is 1.32 per unit. Then we calculate transient fault current. The magnitude of fault current is approximately 5.3 per unit or 1694 amperes. For steady state period, the value of reactance is 0.5 per unit. Therefore, the magnitude of voltage source, e.g. is 1.53 per unit. Then we calculate fault current. The magnitude is approximately 982 amperes. Let's compare the fault currents in three periods. The highest value is in subtransient period. It is higher than 3 kA. Then fault current reduced to 1.7 kA and approximately 1 kA in steady state period. Example 2 use data in the previous example, but three-phase fault occurs at load birth. We use the values of voltage source from example 1. The calculation of fault current is similar to that of example 1, but the current flows through generator reactance and transformer reactance. Therefore, the magnitude of subtransient current is 1222 amp, which approximately 100 amp less than that of example 1. Let's examine fault current in transient period. The magnitude of fault current is approximately 940 amperes and 300 ampere less than that of example 1. Similarly, the magnitude of fault current in steady state period reduced from 982 amperes in example 1 to 702 ampere when fault occurs at farther from generator. Let's compare fault current in three periods. The highest current occurs in subtransient period. Then it reduces smaller and smaller in subsequent periods. Let's compare two cases when fault occurs near and far from generator. Fault at generator will cause much higher fault current than that of fault at load. Can you answer this question? What is the effect of fault location? We can see from examples. Fault at generator terminals is the most severe case. The farther fault current is, the smaller fault current it produces. In conclusions, the value of voltage source depends on load current and reactance. The magnitude of fault current depends on fault location. Thank you for your attention. Please stay tuned for more clips.